So we want the top face of the profile oriented with the right face of each wing. And likewise, the right face of the profile, and that's the direction pointing from leading edge to trailing edge, we would want aligned with the rear direction of the wing. And finally, the rear, turn on just the profile again. So the rear of the profile is pointing back this way, the way it's oriented, and we would want that aligned with the top of the wing. Go back to our code and say the orientation would be alignment top of the profile should be aligned with the right of the wing. We said the right of the profile, that's leading edge to trailing edge, should align with the face normal vector rear of the wing. And finally, the rear of the profile should align with the face normal vector top of the wing. Let's compile that form, Control-C, Control-C, and take a look at what we have. We'll update this and go ahead and draw the entire thing. So there we go. And the wings are not drawing now, notice. Only the profiles are drawing because they're no longer the leaf of this tree. The root profile is the leaf, and we were just drawing leaves on the tree. If we want to add a node, we can select the Add Node mode here and do an Add Node on the wing, likewise on the other wing. I'm not zooming in because I'm still in the Pick Coordinate mode. On my view here, I might want to go back to the Zoom In mode to be able to zoom in. And you can see there's our root profiles. They're oriented, and they look like they might be oriented correctly. Now we have to position them. So for that we want to give a center. And the center of the profile, recall, is at the leading edge center. So we want to place that center at an edge center of this box. This is the right vector, so this would be the left front edge. Edge center. And that takes two keywords as arguments, left, front. It doesn't matter which order we give those in. Let's update, and there is our profile. If we take a front view, we should see that they're flat with respect to the wings. We shouldn't be able to see them at all. We could turn on a bit of line thickness and another color and draw just these profiles. And now you can see them highlight in red. The next transformation we will want is to scale the profile properly. And to scale, we should figure out the ratio between the max thickness here and the actual thickness that we want. We assume we want the profile to fill this entire box. So the 0, 0, 0 will stay as it is. When we scale it, it will stretch back and it will stretch top to bottom. So we want to make this thickness scale up so that it's as thick as the box. So to do that, we would take the ratio of the current thickness of the box divided by the current max thickness of the profile. So let's let the profile be a little bit smarter and compute its max thickness. So that profile, a very direct, somewhat brute force way to do it, would be to find the max x and min x, and we'll do this in a somewhat long-handed manner, just so you can see how it works. There is an internal message for min, max, x, y, z also. We'll go through these points, and these are the actual fit points. So those will be points around the curve. We might as well use those. So the x max would be the most. That's a function where you give it a function and then a list. And it returns the item from that list, which has the highest value when you apply that function. So the function we would want to apply would be getX. GetX returns the x component of a point. The most getX on the points will give us the x max. Similarly, the x min would be the least getX from the points. And similarly, y max and y min. Remember, these points are just a simple common Lisp list, so we use normal Lisp functions. So these are points that get returned. X max will give you one of these points. X min will be a point, and so on. So in order to compute the max thickness, we would subtract the getX of the max x from the getX of the min x. And likewise, to compute the chord, we could subtract the get y and shift meta %. We'll do a query replace. So I want to say I want to replace x with y. So now it's asking me, and I'll say yes, 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 yes. So now our profile curve is a little bit more intelligent because it knows what its max thickness is and it knows what its chord is. And that's all computed based on these points that are passed in. If we pass in a different set of points, these messages will continue to return the correct value. So back down in our wing box now, we know that we can ask the canonical profile for its max thickness.